Hi everyone. Now we are going to discuss about cells, EMF, internal resistance. Cell is a device which is used to create a potential difference in a circuit, and EMF is the potential difference between two terminals of a battery if there is no current flow. Internal resistance is the resistance offered by the cell because of the electrolyte present in the cell. So we are going to discuss these kind of things in this session. So first one, what is a cell? Simple device to maintain a steady current in a circuit, in an electric circuit is electrolytic cell. So we can make an electrolytic cell using zinc sulfate, copper and copper sulfate. Zinc is known as electrode, the metallic rod is known as electrode, and the electrolyte copper sulfate is known as electrolyte. If it is copper, we need to use copper sulfate. If it is zinc, we need to use zinc sulfate. These are the pairs. So it is an electrolyte. We are not going to specify any electrolyte like copper sulfate, zinc sulfate, but you should know what is electrolyte. Electrolyte is a substance which can dissociate into ions. So in electrolyte there will be ions. Because of these ions, the electrolyte is able to conduct electricity. So it is an electrolyte which have ions, and there are two electrodes. These are two electrode A and B, and this electrode is connected to a resistance. We can connect galvanometer also to see the direction of current. This electrode is A and this electrode is B. The electrode and electrolyte, there is a potential difference between electrode and electrolyte. It is known as electrode potential. So electrode potential is the potential difference between electrode and electrolyte. Here the electrode A and electrolyte is having a potential difference. Electrode B and electrolyte is having a potential difference. Because of this electrode potential, and there will be a potential difference between these two electrode potential. The difference between two electrode potential is known as EMF. So electrode potential is the potential difference between electrode and electrolyte, and EMF is the potential difference between electrode potential. It is the potential difference between two electrode. EMF is the potential difference between two electrode. So here the electrode potential of A is more than, we are assuming electrode potential of A is more than electrode potential of B. So there will be a current flow. It will be the direction. Current will always flow from higher potential to lower potential. Inside the conductor, inside the electrolyte, the direction will be B to A, and outside the electrolyte, the direction will be A to B. This is a cyclic flow. And if there is a flow inside, there will be internal resistance. It is external resistance. Inside the electrolyte, there will be internal resistance R. So internal resistance is the resistance offered by the electrolyte in a cell. Potential difference between electrode and electrolyte is known as electrode potential. Voltage is the potential difference between two terminals of a cell when the current is flowing. When we are connecting a cell into a circuit, there will be current flow. Because of this current flow, and there will be a voltage. And at that time, we are measuring the potential difference between two terminals of the battery. It is known as voltage. So it will be less compared to its EMF. Because of the internal resistance, there will be always a small change in value of voltage because of the internal resistance. Using voltmeter, we can measure voltage of a cell. So we can use a voltmeter to measure the voltage of a cell. It is a voltmeter. EMF or electromotive force. Potential difference between two terminals of a cell when no current is flowing through the circuit in an open circuit. It is the potential difference between two terminals of a cell in an open circuit. There is no current flow. EMF is the potential difference between the positive and negative electrodes in an open circuit, that is, when no current is flowing through the cell. Internal resistance, which is indicated by the small letter R. Resistance of electrolyte inside the cell is represented by R, and it is known as internal resistance. Now we are going to derive an expression for internal resistance. We are considering a circuit which is having cell and resistor. So internal resistance of the cell is R and EMF of the cell is E. V is the potential drop across the resistance R. So, and small letter V is the potential drop across the resistance R, small letter R. So it is a cell, and EMF of this cell is E. The resistance of this resistor is R, and the internal resistance of this cell is R. It is E, EMF E, and voltage is V. What will be the total EMF? To find the total EMF, we need to add this voltage and this voltage, V plus V, right? So total EMF is always equal to V plus V. What is the equation for this V according to Ohm's law? Current is I through the circuit, it will be I into R, right? I into R. And what is the equation for this V according to Ohm's law? It is also I into R, small letter R. The current will be same because it is a series connection. Now we can take the I outside. It will be E equal to I into R plus R. From that we can make an equation for R. It will be E by I minus R. It is the expression for internal resistance. These all equations are very important. From that we can make an equation for I, E by R plus R.